Hi students, and welcome to HSC Chemistry and the Acidic Environment video series. In this video we're going to have a look at some of the salts of weak acids and bases. Now, one of the things that we can do now that we have some understanding of things like conjugate pairs is we can start to get a bit of an idea of the nature of different types of salts that form as a consequence of neutralization reactions. So whenever weak acids or weak bases, or strong acids or strong bases for that matter, dissolve in water, we form a salt. So a general equation is acid plus base gives salt plus water. The assumption that we make in most cases is the H plus ions from the acid are going to react with the OH minus ions from the base and produce water. Now this is fine, but the problem is that when certain salts are formed, they may actually be salts that are strong conjugates of acids or bases, and as a result they may actually interact with the water to increase the hydrogen or the hydroxide ion concentration. And this means that they will change the final pH. So whilst we would expect a situation like this to have a pH equal to 7, this may not always be the case. And what we want to do in this video is just have a look at some of the ways in which we can classify salts on the basis of their interactions with water. So let's have a look at potassium acetate. So potassium acetate is a salt. Okay, it's not an acid or a base, it's just a salt. It could be formed, for example, by the reaction between potassium hydroxide and acetic acid. So that would form water and potassium acetate as an ion. Now here we have the potassium acetate, and here it is dissociating into its ions, into its potassium ion and its acetate ion. Now the interesting one here is the acetate ion. The potassium doesn't really do very much to the pH of the solution, so it's not something that we need to worry about. It's not going to be a factor. But this does. When it interacts with water, it acts as the base that it is. And because it is a base, it will accept a proton. But the proton it's going to accept is going to come from the water molecule. What that does is it reforms this very weak base. We know that acetic acid is a weak base, so it remains in molecular form in the water. But what it will do is it will also increase the concentration of the OH minus ions. This will increase the pH of the solution. As a result, what we do with potassium acetate is we classify it as a basic salt. That's because the acetate ion can interact with the water molecules in order to increase the pH of the solution and make it more basic. Now this of course applies to a number of other salts as well. So it means that each time we're looking at salts, we can actually start to classify them. Sodium chloride would be a neutral salt because sodium chloride, when it dissociates into its ions, forming sodium ions and chloride ions, we know that the chloride ion is actually the conjugate base from hydrochloric acid. So this is weak. So there is going to be minimal interaction from either ion with water. And hence the pH of this solution is going to be roughly equal to 7. Ammonium salts are acidic because ammonium is an ion and it interacts with water in such a way as to behave like an acid. It means the water behaves as a base and it will take in that proton, that H+, and leave NH3 as a molecule in aqueous solution. But what this will do is this addition of hydronium ions will increase the concentration of H+ and as a result will decrease the pH. Therefore, we have a pH which will be less than 7 and therefore an acidic solution. A carbonate salt, on the other hand, is a basic salt. Can you show that it's a basic salt? Well, carbonate ions, CO3 2- ions, will interact with water molecules in such a way as to make the water behave like an acid. They will behave like a base. They will take the proton from the water molecule to form a conjugate acid. But when they do that, they will leave the conjugate base of water, which is the OH- ion. And as a consequence of that, concentration of OH- will increase, and therefore the pH will also increase, leaving us with a pH greater than 7. Understanding the nature of the types of ions that form, or at least are released when different types of salts dissociate in water, and how those ions interact with water, helps us to be able to classify salts as either acidic, basic, or neutral. Thanks for watching.